Good morning, all. Well, I shouldn't say good morning. It's good morning for me, but probably 11 at night for some of you, and maybe it is good morning. Maybe it's 4 in the morning for some of you. But anyway, this video is going to be on constraints. So generally I do a lesson on constraints, but I wanted you to have some reference material. So what I'm going to do is I'm going to go through all of the constraints and what they do and how they work. So let's get started. So we're going to start a sketch, and I'm just going to draw some random geometry throughout this just to kind of demonstrate the constraints. So we're going to start up here in the upper left-hand corner, and we're going to work our way across and down. So I'm going to kind of read it like a book. All right, so our first constraint is the coincident constraint. And what that constraint does, it actually just makes two things coincident. So it'll make it potentially here, it'll make the end of this line coincident with that circle. And it can do it a number of different ways. You notice that it moved the circle here. Well, it doesn't necessarily have to move the circle. It's probably a 50-50 shot on which one it moves if nothing else is constrained. Now, if I were to have this circle constrained to a location, say I were to constrain it by dimensioning it from the origin, and now I do this coincident constraint, now it moves the line. So it really just depends on what constraints you already have existing on how it affects your drawing. And that lends a lot to drawing intent. So just be careful when you're doing these constraints. Now the other thing we could do is if I delete these, I can make this coincident to the origin. So now everything's moved because this line is coincident to the center of this circle, or the endpoint of this line is coincident to the center of this circle. And then I also made the center of this circle coincident to the origin. So they all have to meet in the origin. All right, let's move on to collinear. So a good example of where you're going to use collinear is going to be if you just want two things to align. So let's say I have kind of like a fork type, or a part with slots in it, let's say. And I'm doing a bunch of these just to kind of do some different demonstrations here. Okay. Now again, if none of these are defined for a height, then you're going to get all kinds of different heights. It's just going to depend on which one it changes it to. So I'm going to define one of these so that we can see it aligning them all to that height. So what I'm going to do is I'm going to define this one. And I'm going to say 1.0. So we're going to make that 1.0. And I'm also going to define this distance here to 0.6625. All right. Now, notice that this one turned purple. Well, the reason that one turned purple is because when I was drawing this, so let me try the collinear. It's saying that adding this constraint will over-constrain the sketch. Basically what that means is it already has a collinear constraint on it. And what happened when I was drawing this, notice I have these tracking lines. So right here I have that tracking line. And that one actually didn't do it. It's going to be a solid tracking line. So this one actually is not collinear. So if I go to make this one collinear, it'll allow me to do it. But when I was actually drawing this part, let me draw a new one. I think it's because I'm finished that command. So if I were to draw a new one, and if I come up, see that solid line is created now. I have a tracking line, and then I have that solid line. That is creating the collinear constraint automatically. So those are automatically collinear now. So that's basically how this one already got collinear to this one. All right, so what I want to do is I want to make sure that these are all collinear, and I want all the bottom of these slots to be collinear. So I'm going to pick my colinear, click on those two, click on those two, click on those two, then I'm going to click on here. And now these are all lined up. So all these lines are basically on the same y-axis dimension in this case. It's y. So that's basically what Colinear does. Concentric, well, Concentric's probably pretty self-explanatory, but let's go ahead and go over it anyway. So basically all Concentric is going to do is it's going to make something concentric to something else. So to make an arc concentric to another arc. Probably a better way of saying it. So it's going to make those two concentric. And of course, it moved the small one. 50-50 chance on which one it moved. Just depends on which one is constrained. So if I had constrained the small one, dimensioned it from the origin, it would have moved that one. So I'm going to undo that, and I'm going to use this lock button. So next is the lock. Basically, what it does is it fixes things in the position that they are relative to this coordinate system, just as it says here. So without dimensioning it, it's going to lock that location. All I can do with this is I can just make it bigger. I can't move it in the X or Y axis. So it's locking it in position X and Y without creating dimensions for it. I don't recommend using this very often. I recommend using dimensions. So the only time I would use this is maybe in if you had something floating that just didn't matter, but you really should always have things anchored somewhere to your origin, because when you go to assemble things later, you really don't want them floating out in no man's land, just locked out there. You really want to have them close to your origin so you have a point to reference from if you have a difficult to assemble part. You can reference that origin and an offset, a dimension from that origin to mate it to something. So now I'm going to go back to my concentric. And I'm going to make this concentric, and now you see it moves the larger circle to the smaller circle because this circle, first circle's position in that plane is defined. So it cannot move. So it has to move the bigger circle. Obviously, if this should be just intuitive, if I have them both locked and I try to hit concentric, it should tell me I can't do that, basically. Say, we'll over-constrain the sketch, and I can't do it because they're both locked. There's no way of moving them over top of each other. So let me undo that. Undo both of those locks so they're not locked. I can move them if need be. Next, we are going to move on to the parallel constraint. This one, again, pretty much self-explanatory. I mean, all you're really going to do here is, let's just say I have two lines and I really need them to be parallel, but I just sketched it out real quick and I didn't take the time to make sure that they were both parallel. In fact, it's more likely that I want it to be parallel with this one because this is a horizontal and I can snap that, right? So when I'm drawing, obviously it's easy to snap a horizontal line. It's a little bit more difficult, a little more work to get an angle because what I'd have to do is type in the angle there. So I might just want to be parallel to this one. Well, I don't know which one it's going to move. So let's try it, see what happens. Okay, so it moved that one. Let me see if they're... Yeah. So it doesn't matter which one you click first. I didn't know if they might have changed this in 2021 or not. But doesn't matter which one I click first. It's just basically going to do whichever one it feels like. Yeah, it doesn't care. Let's see if it, oops, undo, there we go. Gonna see if working left or right works. No, it really wants to make it parallel to that one. So that's not what I want. That's the problem. So what I'm gonna do is I'm gonna define this one. And let's give it a defining point in space. And we're going to give it a dimension. Okay. So now if I select that, what did I pick there? Parallel, parallel. We'll over constrain the sketch. Oh, so this is actually a good segue. So if I click on this, you can see that I have a button up here. It's called Show Constraints. So if I go and click on that Show Constraints button, I hover over this line, it's going to tell me I have one constraint on that line if I look down here in this. So right there is my one constraint. I can click on that constraint and I can delete that constraint. Now this is free to move any way it wants. So before I couldn't make it parallel because it was a horizontal constraint. And that is also why it would absolutely not go any way but horizontal, which I did not think of at the time. I didn't realize I put a horizontal constraint on that. Anytime you do this, you can see there in just below the cursor, the lower right above the degrees, that is a horizontal constraint icon. That means it's going to automatically apply that. Likewise, the vertical constraint if I go vertical. So if you don't want something with a horizontal constraint, you got to go off axis a little bit. So let's try this again, and there we go. Now, it's not going to move it like this, like you typically think of parallel lines. It's just going to put it in parallel with it. Doesn't matter where it's at, it's still in parallel with that line. So if you want to get it, offset from there or something like that, well, you're going to have to do some dimensioning and send it over there. So I'd have to send this thing over, and basically I could make, well, I'll do that here in a second. We're going to skip over perpendicular. I'm going to go to vertical and horizontal. So I'm going to start with vertical here. And what I can do is make that vertical, and I can make this point vertical, and I can dimension this 0.5, and now it's fully defined. So what I did was basically just align those points, so that's, since this distance is defined on the lower one, well, it's got to be defined on the upper one, right? And since I know how far it's offset, it's fully defined. Okay, so let's go to perpendicular. Perpendicular is exactly what you think it is. It's just going to make them perpendicular. It's not going to make them coincident. When people think of perpendicular, they think automatically of a right angle. Two lines that are connected at the 90-degree angle. Well, it's not going to do that because you are not defining that. All you're telling it is they need to be perpendicular. They're oriented 90 degrees to each other. That's it. If you want them to connect, then you need to use the coincident command as well and connect them. So let's look at horizontal. I didn't use that one yet. It's obviously the opposite of vertical, right? Let's turn this horizontal. Well, we know this already has a vertical constraint on it because when I drew it, I know it says two constraints there. So I got one here is horizontal, and then of course it's got my 90-degree constraint. Well, I don't want that that vertical constraint on there anymore. And what's this one have? Let's go hover over this one. Let me escape out of there quick. So that only has one constraint on it. Okay, so let's say we want to make this line horizontal. So I'm going to hit the horizontal, select that line, and it's going to make everything, it's going to change both of those because this is horizontal and this is 90 degrees to it. Again, which way it flips it depends on how many constraints you have. This is unconstrained other than this 90 degrees. So it's a 50-50 shot on whether this line is pointed down or pointed up. So if you want to make sure of that, what you need to do is you need to pre-constrain it. You need to add some constraints to that to make sure it rotates it or moves it the way that you want. We went over vertical. Vertical just aligns things vertically. Now, the way I use vertical and horizontal are usually not in this fashion. The way that I generally use them is to align circles. So I'll be drawing something, and generally I'll want to align a circle center point with maybe the end of a line, or maybe the origin, or something like that. That's usually how I use horizontal, so or vertical. So if I do horizontal to there, it's going to align the center of that to that point horizontally. And if I want to do vertical to here, it's going to align that vertically. That is the way that I use them more than anything. Next, we can go to tangent. So let me draw a bigger circle here for this one. And say I have a line. And actually, we could do this one too. Let's do this line first. So I'm going to go pick my tangent, and I'm going to send that tangent to it. Now, of course, again, and I know I sound like a broken record, but yeah, it's going to move whichever one. It's going to be a 50-50 shot because I don't have either of them constrained. So that's what it's going to do. Now, as I move this, right, it's always going to be tangent. Doesn't matter. It's always going to be tangent to it. That line is still tangent. If I extend it, it's still tangent. It's always going to be in tangency. Let's do this. Let's add this line and make this line tangent. Okay? Now let's add this line and make it tangent. So those are tangent. It's just a matter of which direction that goes. But all three of these lines are tangent to that. Now, this is kind of constrained, this circle, because since this is constrained as horizontal, then it has to be in this lower left-hand corner. And what I could do to really constrain this, I could actually add another tangency off of here. So if I had another line per se, maybe like this, and if I dimensioned it to there, check, and I put an angle on it as well, check, and now if I make this tangent, it should define this circle. Of course, all of these dimensions have to be tangent too, or sorry, have to be defined too. But basically, it's going to define the size of that circle. There's really no way for that circle to be any bigger at this point. Okay, so and by define that circle, I meant define the diameter, of course. Okay, so next one is our smooth command. So this one here, I've only ever used this like once or twice. I haven't used it very often. So I'm going to go over it, but you're probably not going to see this one very often. So I'm going to create a circle. I'm going to create a line down here, and we're going to create a spline that connects these two. So I'm going to come from here, and I'm going to make sure it's not smooth. Right there to the quadrant point. I'm going to hit check. All right, so the other thing I'm going to do here is I'm going to define these locations. Because if I don't, the smooth command might actually move those to make it smooth as opposed to changing the spline. So I want you to see how it changes the spline. Because what we're assuming is that, you know, this arc and this line are the center point of the arc and the end point of this line are at the correct position. And we want a spline that transitions very smoothly between them. So I'm going to hit check, and I'm going to make this coincident to the origin, which has disappeared. So I need to go into my center point because I deleted it. Create it again, just hit project geometry. Come to my center point. Oh, shoot. So I do need to define that. And now I'm going to go to my origin. Okay, so there we go. All right, so what I'm going to do, the first thing I need to do is I want to make this tangent to. So that's tangent to that circle. And now we're going to pick our smooth transition. And you can see there it kind of creates this smooth, splined transition here between the two. And it's still tangent to this circle. So that's essentially what that does. You can see that that shape is probably not a shape you're going to use very often. So that's why I barely ever use it. Like I said, I've only used it a couple times ever. So that's what that does. Oops. Let me delete all this stuff. Bring my center point back in case I need it. And our next one is symmetric. Okay, so what I'm going to do is I'm going to click on this construction icon, and I'm going to create a construction line. And basically all a construction line is a line that's dotted, and it's not seen by extrusions or feature creation. So it's just there for construction purposes in this case. So what I'm going to do here is I'm just going to create a line, and I'm going to create another line that's obviously not symmetric to that one. And I'm going to click my symmetric constraint, and I'm going to click my first line and my second line. So I'm going to click this one, my second line, and then I got to click the line that is this line of symmetry, which is the center line. And it'll tell you what to do down here. So if you ever go through a command and you're not sure what you need to click on, down here in this this lower left-hand corner, it will generally give you instructions on what you're supposed to do. So you can see there, now they are symmetric. Now, by symmetric, it doesn't mean they're the same length. It doesn't mean that they're the same distance per se. They actually are the same distance from here, but it just means they're symmetric. So that essentially is not the same distance, right? Because doesn't need to be symmetric over this axis. It needs to be symmetric over this axis. Oops. But the line angles will be. Basically what you're doing is creating a mirror image. You're making it mirrored over this line. Again, not a command that I've used very often. So let me delete that. Let me not get my center point in there. Delete. And okay, so last we have an equal. This actually comes in handy a lot. So let's say, wow, I'm really zoomed out. Say I have a bunch of circles, right? And I want them all to be 120 diameter. Well, I could go by and dimension all them. I could also just hit equals and keep selecting them until they're all the same size. So they're all reliant on this one. So now they're all tied to this one. So if I change this into 140, they all change to 140. So that's the advantage of that command, right? If I have a bunch of circles that need to be the same diameter, and then I come back later and I think, oh well, I really want to make them a little bit bigger. Well, if you dimension them all, you have to go through and change every dimension of every circle. Here, you only have to change the first one, and it'll carry through. So that's a very nice command to have. All right, so last thing I want to go through here in the constraints, I want to go through, actually, maybe second last. I might take a look at the constraint settings. Just know that these are the constraints. I'm not going to go through all these, but display coincident constraints in a sketch, so it'll just show that little icon. Interference, so selection for constraint interference. You can go into here and change some of these settings and enable some relaxed mode on it. Constraints to remove in relaxed dragging, so you can basically it'll remove those constraints if you're trying to drag something. But I like them the way they are. You really probably shouldn't mess with those too much unless some kind of special circumstances. But the last thing I want to go over here is I want to go over this auto dimension and constraint. So This is an icon that I hesitate to show students too quickly because students want to just press this and be done, just constrain their sketch and just be done with it, right? But that can cause a lot of problems for them. So what happens is, let me draw something here. So I'm just going to draw something goofy like that. Okay, so let's say that they think, oh, all I want to do is make sure that this is 1,600, and I want to make sure that this is 900, and this angle should be 100 degrees. But that's all I really care about, and for some reason I'm stuck in. There we go. So, by the way, if you ever draw anything by accident in construction mode, you just select it all, click the construction mode, and it'll turn it back. And then make sure you click it off because it will stay on. So I accidentally clicked that somewhere along the line. But then they'll be like, okay, well, I don't really care about the rest of this stuff. Okay, just auto-constrain it. It says I need 6 more dimensions. Yeah, just apply those. Done. Okay, so number one, this doesn't know what your intent is, your drawing intent. So if you go back later to change something, it might not have the constraints that make it easy to do that. So you might have to go delete a bunch of dimensions and constraints. It might just be easier to redraw the sketch sometimes. So I do not recommend this unless you're really in a bind. And the way I always use it, I will do all of my dimensions. So let's say I want these to be colinear, and I want this to be 500. This is going to be the same, and this is going to be 600. Yeah, that's defined already. That's going to be 500. Okay, so let's say that's what I want. Okay, I need 2 dimensions. Darn it, what is going on? Like what? I can't figure out what 2 dimensions I need. So what I'll do is I'll go in and I'll click this and I'll hit apply, and I'll look and see what it added. And I actually don't see what it added here. Apply. Oh, maybe. That's interesting. So let me give that another try. Apply. There we go. All right. So I've got this thing to move. Doesn't seem to want to apply them though. Let me delete this one, see if I can get that one to apply. The pitfalls of doing this in real time. So it applied this one, right? But you see that that's not the constraint that I wanted. I wanted the overall constraint. Now, that changes things a little. Now, it's right now, but that it's not the way that I dimensioned it, right? It's not. It might not necessarily meet the design intent that I want. So it doesn't look like it wants to apply the locational tolerances, which is interesting. So what I'm missing here, obviously, is the location, right? This can be dragged or drug in anywhere in the XY plane. So if I just make this coincident to... Oh, I know why it wouldn't work. My 0 is gone. Okay. I was wondering what was going on there. So, lesson right there. I actually didn't realize that was what it was going to be, but... So apply that. Center. What the heck? There we go. No, wait, what's going on here? Oh, I clicked out of my sketch, I think. Center point, project geometry. Okay. So now it's projected. Now let's see if it'll work. Apply. There we go. So since it didn't have that center point, it couldn't apply that geometry. So that makes sense. I'm actually, and that is exactly why I do these in real time, because that is definitely something that I could see happening to a student and them not being able to figure out. Because it took me a couple minutes to figure out what's going on. I didn't notice it was gone until I went in there to actually apply the constraint, right? The coincident constraint. So this is what I'll do. I'll apply this, see what I'm missing, and a lot of times it will look like this. So like in this situation, it won't look the way it is. It'll look something like, like that, right? And it might even be better. It'll be probably closer like that. It'll be like this, right? And it's not actually constrained. In fact, it's not at 0, 0, but it looks like it from here. So I think, oh, well, I have everything. I don't understand what I'm missing. I'll go in and I'll use this to figure out what I'm missing. And then I can see, oh, okay, it's dimensioning. I see I'm not at 0, 0. So I'll remove those, hit done, and then I'll go and I'll just apply a coincident constraint to there. And now it's done. Of course, I am still missing that one that I deleted out. But if that's in there, then we're good to go. So now we're fully constrained. So that's how I recommend using this. Don't just click it and take what it gives you. Define it the way you want it defined, and then use this to figure out what is missing. That is the best way that you can use that tool. For this lesson, that is all. So if you have any questions, as always, you can see me during my office hours, or of course, you can see me during class.